So now I just came across this diagram I drew a long time ago, so I thought we'd cover this again. This is not the best way to parallel LEDs. Instead, you should give one its own resistor and then the other one its own resistor going to the positive supply and using the resistance you want to set the current. If you have them in parallel like this, make sure you put them in the right way, then they probably will divide up the current about in half. But if one of them burns out or something, the other one's going to take all the current. So again, you got to make sure you have a resistor that is a low enough value or high enough value for just one of them alone. You don't want to go too low so that you get twice the current unless one burns out, because the other one's going to take all the current. And you'll see that right here when I plugged this, that one got brighter. So I got another resistor also to the positive supply. I got to turn the LED around, turn it the right way. You should give each LED its own protective resistor. So now, you shouldn't parallel LEDs like this. You should give each one its own protective resistor. But there is kind of a use for this. We'll come to that later. But in case, if we did parallel a red and a blue LED, the red LED has a lower forward voltage. So all the current is going to pass through it. None of the current is going to pass through the blue LED. But if the red LED burns out or something, the blue LED will light up. So we'll demonstrate that. We got both the LEDs right there. So if the red one burns out, it will probably stop conducting altogether, and then we will have the full voltage across the blue LED. So sometimes something like this is used to determine if a part went bad, if it stopped conducting. Then that extra voltage will build up across a light or something. It will start flashing, or some other alarm will happen. So that's one use for it.